Thanks for sticking it out for the afternoon. Thanks for being here. I want to talk to you this afternoon about some really exciting research my colleague Gary Giannini and I have been working on the rivers in southwestern Colorado. So we talk a lot about the impact of regulated river flows on the health of floodplain forests. And we spend a lot of time talking about how that impacts the spread of exotic species. But there's also some interesting stuff going on with native species. And so I'm going to focus on the two dominant woody vegetation types in southwestern Colorado, cottonwood species and willow. And the main ones in our study areas are narrowleaf cottonwood and coyote or sandbar willow, Salix exigua. They do have similar recruitment needs in terms of the types of hydrology they prefer. And they also both have the potential to overlap habitats with exotic species. So a key question we became interested in as part of this larger research project is how these two species respond to flow regulation and the associated changes in hydrology. So we know that there's a loss of high flows when you put a dam on a river, and there's a loss of associated bank scouring. We also infer that there's going to be a loss of groundwater recharge in the floodplain, and so we wanted to look at that in more depth. And we all often, as I mentioned, talk about how river regulation impacts exotic species. So here's our study area. We've worked in two different watersheds in southwestern Colorado, both of which are part of the upper Colorado River Basin. We have study sites on the Dolores River, which flows north into the Colorado River upstream of Moab, Utah. And we have a study site above the reservoir, above McPhee Dam here. And then we also have study sites below the dam. So we have unregulated and regulated sites on the Dolores. And then we also have some newer sites on the Animas River, which flows south into the San Juan River in Farmington, New Mexico. And that's also an unregulated river reach. So methodology, quick overview. We've divided our sites into two different geomorphic features. They're two distinct surfaces. There's the active channel margin or point bar, which my students affectionately call the beach. And you can see that in this image of the Animas River Valley marked by letter A there. That portion of the floodplain is mostly impacted by bankfull flows. And then we have a slightly more elevated upper floodplain, which is set back a little bit farther. We sampled vegetation on the beach using meter square quadrats. And in the upper floodplain area, we looked at woody vegetation cover along line-intercept transects. And the really exciting part of this research has been related to the hydrology we've been able to incorporate. We have, of course, river discharge data from USGS stream gauges along these reaches. But then at each site, we've also been able to put in 3 shallow groundwater wells to monitor groundwater depth at each site. And here is Dr. Giannini. Oops. Oh, never mind. Here's Dr. Giannini installing one of our data loggers with some very enthusiastic Fort Lewis College students. So what I'd like to do is give you a quick overview of some of our results from this research, giving you a look at the differences in surface hydrology in these different stream reaches. And then we'll zoom in and look at the beach zone specifically and look at vegetation trends on that beach as well as groundwater hydrology variation. And then we'll move back a little bit and look at the upper floodplain, looking again at vegetation trends and then also at groundwater variation. And then finally, if I don't take too long, we'll have a few conclusions. So let's start with surface hydrology. And as you can see in this series of hydrographs, we've got discharge. I'm sorry, I'm really bad with pointers. I must have gone way too far. Here we go. Back up one more. Okay, maybe. One more back. Thanks, Jesse. So this is a typical hydrograph for rivers in our region with the peak during spring snowmelt. And we have, I'm going to skip the pointer because I'm so bad at it. We have the blue curve shows the hydrograph of the Animas River, which is unregulated. And the red curve is the upper Dolores, so above the dam, also unregulated. And then the green curve is the Dolores River below McPhee Dam, so it is regulated. Notice that we have a very reduced peak hydrograph in the spring on the regulated Dolores River. And a couple other interesting things on that green curve to notice is the early low elevation snowmelt in March on the lower Dolores. And then also in some years, like this one, 2010, when we have a good monsoon, you'll see some late summer spikes in the hydrograph as well. Contrast this is a fairly normal year with 2012, extreme drought. And the peak flows on that last slide on the Animas River were close to 6,000 cubic feet per second. As you see here, it just barely topped 2,000 CFS. So we have much reduced spring flows, even on unregulated rivers. But notice that the green regulated curve on the lower Dolores River has essentially no spring spike at all. We know that those spring peak discharges are critical for groundwater recharge on the floodplain. So that's going to have a huge impact. Let's look now at the beach zone for a few minutes. And we're going to look at vegetation trends over time. Here are a couple of aerial photographs of the Dolores River below McPhee Dam. And this is an image from 1973. You can see there's a large sandy beach. My students would have loved it. They could have gone there. The dam was completed in 1984. And so by 2009, that sandy point bar area is now filled in with vegetation. And we know that that's dominated by willows, mostly Salix exigua, sandbar willow. We can compare across sites as well in terms of vegetation, and we see some interesting patterns. Here we've got percent cover of a series of different variables on these 3 reaches. The blue bars represent the Animas River, and the red bars are the unregulated Dolores. And notice that, I'll try this again, see if I can not mess up. Notice that percent cover of bare ground and rock is significantly greater on those unregulated reaches compared to the regulated Dolores River, which has almost no bare ground. In contrast, we have really high amounts of litter and woody vegetation cover, significantly higher on the regulated Dolores River versus those 2 unregulated reaches. And here's what that looks like. On an unregulated river, we have wide open sandy point bar, plenty of places for young seedlings to become established. In contrast with the regulated Dolores River, where we have pretty thick willow coverage, and my students looking really sad there because there is no more beach. Here's some interesting data from the groundwater. So now we're looking at again, the Dolores River below the dam, so regulated reach of the river, and these are now these are now groundwater data showing the depth of groundwater below the ground surface, shown by the brown line there. During high flow periods, the well is slightly inundated, but notice that during low flow periods, late in the summer, it's only about 0.6 meters down to groundwater. So that's plenty of water to keep willows happy, get their feet nice and wet. We can compare that with the situation above the dam on the Dolores River. We can sort of compare it. We unfortunately don't have a great data set for here. But again, notice there's the brown line represents the ground surface. And during high flows, again, the well would be slightly inundated, so we have that little orange peak. But again, by late summer, at least in a wet year, it's only 0.6 meters down to the groundwater, down to the water table. Unfortunately, we do not have a complete data set here. This is such a rocky site that it took us until July of our first year to get the well established. And then the following year, in the high flows, in May, the well broke off, and it took us until July to get that data logger out of the sediment. So we don't have any drought year data from this site, unfortunately. Equally unfortunately, if we can get a new well put back into this site, we might have a chance to get those data this year. It's looking pretty bad as far as droughts go. So let's step back now and look at the upper floodplain. And we're going to look at briefly at trends over time in vegetation cover. I'm not going to spend a lot of time on this one, but the red points represent cottonwood canopy cover. And we're looking at changes in cover over time compared with peak discharge in the river hydrograph. This is the site below McPhee Dam. And I noticed that as discharge declines, cottonwood canopy cover declines substantially. When we look at comparisons in the vegetation cover on our different reaches today, we see a similar pattern. The two unregulated sites have significantly higher cottonwood canopy cover, so these are mature cottonwood trees, versus the regulated site, which has very much lower canopy cover. We also have higher willow abundance in the understory on the upper floodplain on the unregulated reaches versus regulated. And we also have more vegetative resprout of narrowleaf cottonwood on the upper Dolores River than we do on the regulated Dolores. It's not very high on the Animas, but that's a different story. I can tell you about that later if you want to. Here's a really cool part, groundwater. So this is the regulated Dolores River. We're below the dam. And again, we're looking at depth to groundwater. And notice that even during a wet year, 2011 was fairly wet. We had high discharge. Even during a wet year, early in the season, it's 1.5 meters down to the water table. By late in the growing season, it's 2 meters. In a good year, it's 2 meters down to the water table. In a dry year, 2012 is our drought year, and that's the green, this green line. Unfortunately, we had vandalism at our site. Somebody stole our data logger. And so we can see that line declining, but when we went out there in October and measured depth to groundwater, we found that well was dry. So that means we had, the water table was probably below 3 meters. And that's pretty far down for those poor cottonwood roots to reach. In comparison, we look at the site upstream of the dam on the Dolores River. During a wet period, it's only 0.5 meter down to groundwater. And by late in the season, it's only 1.5 meters to groundwater. So this makes us wonder if what we're seeing here is potentially a threshold for the survival of mature cottonwoods on these floodplain surfaces on regulated rivers. So, to wrap up, you see these big changes in hydrology, and we know that they've had significant impact on floodplain vegetation. But it's interesting to note that it's affecting the native vegetation in different ways. They're not both responding in the same way to these changes in hydrology. The willows, Salix exigua in particular, are increasing in abundance with flow regulation. And we presume that this is partially due to a lack of flood scouring. We're not having those big peak flows in the spring, and so we're not getting scouring of the point bars. But we also speculate at this point that it's partially related to the higher summer base flows that we see in the regulated river. We don't get big spring peaks, but we also never get really dry or really low riverbeds anymore. And willows like to have their feet wet. Their roots often grow down into the water table, so those are ideal conditions for willows. They're also ideal conditions for Phragmites, which we heard about this morning. And lower down on the Dolores, in the lower Dolores, that's what is armoring the banks down there. You get a mix of willows and Phragmites. The cottonwoods have an opposite response to river regulation. Their abundance, as I think we all know all too well, has been decreasing over the long term, and we see a significant difference between regulated reaches and unregulated reaches in terms of their cottonwood canopy cover. And we're fairly certain this is due to the lack of groundwater recharge. You have to have high peak flows in the spring to recharge that floodplain water table. And that drives the water table deeper below the average rooting depth of cottonwood. Groundwater declines of greater than a meter over the course of one growing season have been shown to cause extreme stress in cottonwood trees and canopy dieback. And this, right, go again. Oh, I always push the wrong button. Okay, this image, thank you, Jesse. This image here is from the Dolores River below McPhee Dam, and if you're close enough, you can see there's a lot of bare canopy, a lot of bare branches in that cottonwood canopy, and a lot of dead down wood. So, okay, it's the Tamarisk conference. We have to talk about exotic species a little bit. This is kind of interesting in a relation to Mike's talk. There are Russian olives invading on the Animas River, and in that case, they are coming up under the cottonwood canopy. There's not very much Russian olive in the reach we're studying. Most of that, it hasn't been too dense, hasn't become too dense yet, and so mostly we've been able to stay on top of that. The city of Durango is doing active, aggressive Russian olive removal. But if you go downstream just a little ways into New Mexico, as some of you probably know, it's a solid Russian olive canopy. On the lower Dolores River, it's tamarisk that has been the invasive exotic woody species. And again, it mainly has invaded within the cottonwood zone, not so much in the willow zone. But thanks to major removal efforts on the part of the Dolores River Restoration Partnership in conjunction with the Tamarisk Coalition, and our friends the beetles, that most of that tamarisk has been knocked way back. So it'll be interesting to see what happens in that part of the Dolores River drainage. So the conventional wisdom has tended to be that river regulation favors exotic species, and we know that's true to some extent, but we also know that exotic species have also been able to invade unregulated river reaches across the West. And now we also can see that a lot of times it's certain groups of native species that can be favored by river regulation. And in this case, it's the native willows that have really taken off on a lot of sites. So with that, I would like to acknowledge the help of a whole cadre of Fort Lewis College undergraduate students, both in field ecology classes and research students, including a few specific ones who have worked with us more recently, as well as our funding from the U.S. Bureau of Reclamation and the Fort Lewis College Foundation. So I think I rushed fast enough that time for a few questions. All right. I don't know for sure, but I wouldn't be surprised if bird dispersal, because birds perching on cottonwoods and leaving their droppings, I wouldn't be surprised if that was an important factor. Certainly you see Russian olive coming up along fence lines, right, where birds perch on the fences. The other thing, though, is that Russian olive, is, as probably all know, is a secondary successional species, so it likes shade. So it comes up best under the shade of other species. So in that regard, as Mike was saying, cottonwood certainly would facilitate the invasion of Russian olive, I'm sad to say. Yes?
Do you see a pattern of in the ground, on your groundwater wells, of sort of a loss of groundwater away from the channel? Because both above and below the Dolores are perennial, and so the absence of groundwater recharge would suggest that you would see that pattern where you see a kind of a slope away from the channel.
Yeah, absolutely. I thought I didn't have time, so I took that slide out, but one of our students, Colin Honest, did some interesting work and was able to show that most of these river reaches alternate between, they might be a gaining stream in the spring, but they switch over to being losing streams in the fall. And these are our transects of 3 wells at the site below the McPhee Dam. And here in the spring, groundwater levels are higher, farther from the river. And so the river is gaining water from the water table. But by summer, later in the summer, water table levels are lower, farther from the stream, and so it becomes a losing stream. And that's very apparent in our sites below the dam. Yeah, good question, thanks.